Hi guys, thank you for joining me for chapter 10. So chapter 10 is our last learning chapter. Thank you guys so much for joining me in this course. I hope I helped. So this course is going to be the sum of everything we learned. So everything we learned was building up to this moment. I'm so proud of you guys. Thank you for joining me on this journey. I'm so happy to put this course together for you guys. Thank you so much. So chapter number 10 is the mechanistic imperial pavement design. So this is the creme de la creme of pavement design. This is when you are really showing your engineering prowess when you're using the mechanistic empirical pavement design. So from our science background, we know that mechanics is the science of motion and the action of forces on bodies, right? So like having a mechanistic approach seeks to explain the phenomena by only referencing like the physical causes, right? But in pavement design, the phenomena are stresses, strain, and deflection, right, within a pavement structure. And the physical causes are loads and the material properties of the pavement, right? So the relationship between these phenomena and their physical causes is typically described using mathematical models, right? And various mathematical models can be and are used as most common practice is like the layered elastic model or the finite element model, right? Along with the mechanistic approach, empirical elements are used when defining the value of the calculated stress, strain, and deflection results in the pavement failure. The relationship between the physical phenomena and the pavement failure is described by empirically derived equations that compute the number of loading cycles to failure. So we bring in the empirical side from the mechanistic side to be able to calculate our load cycles. That's where the equations we use for are empirical. That's why it becomes mechanistic empirical. That's where the two join. That's what I'm trying to get across here, in case you didn't understand the jargon that I was using. Okay, so let's move on. The basic advantages of the mechanistic empirical pavement design method over a purely empirical one are: it can be used for both existing pavement rehabilitation and new pavement construction. It accommodates the changing load types. It can be better characterized material following, better utilization of available material, accommodating new materials, and improved definition of existing layer properties. So when we say better utilization of available materials, that's why I was saying that sometimes you don't have the materials you need. So if you're using a mechanistic empirical pavement design, if the aggregates you require are not native to the region you're in, you can then use it specifically for aggregates you know are readily available. Or if you plan on recycling the asphalt that you're going to remove from that section that you're rehabilitating, right? You can then incorporate recycled asphalt into your design. So you can take that asphalt, send it to the lab. They can give you all the parameters for that asphalt, and then you can incorporate it into your design, and it'll be a specific design to that aggregate that you plan on using for your design. And this also, it improves the definition of the existing layer properties, because also remember, you can go and use that deflectometer to see exactly how the existing road is performing. So that is why the mechanistic empirical method is best for situations like that. So typically you won't be using the mechanistic empirical pavement design method for small projects. Typically, you'll be using them for very large projects. For example, in South Africa, you'll be using them for things like Sanral, maybe City of Joburg, but usually Sanral. Yeah, for like Sanral, regional roads, large roads, rehabilitation, or maybe if they're building a new road, things like that. And then in New Zealand, you'll be using it for Wakakaito. So those big projects where they're either putting in new roads or rehabilitating roads, because there tends to be a lot of slips here. Like in the winter time when it rains, there are a lot of slips because some slopes get inundated with water, and then that causes failure because they are saturated with water. Slips happen, a lot of slips happen. So in that case, you'd be using the mechanistic empirical pavement because it's for a specific design for a specific road, and we're dealing with specific material, and it's worthy for the client to use. And that's when we go into aggregate matrices. Should you use a geotextile to lock in aggregates to enhance your aggregate matrix, things like that. So that's why it's important, right? So it also uses material properties that relate better to the actual pavement performance, like I was just saying. It provides a more reliable performance predictions, like I just said. It better defines the role of construction. Yes, you then know what type of construction methodology you're supposed to use. or you can better define the construction methodology, and it accommodates environmental and aging effects on the material, which is extremely important. So yeah, so this sums up all the advantages of using the mechanistic empirical pavement design method. Yeah, so that's the crux of it, you know. So this is something highly specialized. It's not just something you're just going to be doing willy-nilly. It's something very highly specialized, you know. It's very highly specialized. So my course is not meant to make you an expert. It's meant to make you aware of the things you need to know and the things you need to look at. So after my course, the idea would be then you can go look at designing aids. You can take up, maybe you can take up one of those online courses on how to use the software from the supplier, because some of these softwares are really expensive. We'll talk about the softwares later though, but some of these softwares are so expensive I can't buy them and have a course on them, because that would, you know, that would most probably bankrupt me, because some of them are really expensive. So the idea is they're supposed to be bought by an organization that are going to make a higher profit margin using the software. So that's when you guys can start looking at it, you know. So my course is meant to be a cheap introduction so that you guys can have the knowledge to know where to look for. Because one of my lecturers, I think her name is Dr. Maria, or Professor Maria Ferentino, I think she now teaches at the University of Liverpool, always says that the idea of us when you're being taught engineering isn't so that we spoon feed you the answers, but the idea is for you to be able to know where to get the information when you need it. So if you ever come across a situation where you need to do a mechanistic empirical design, or you need to do an empirical design or a mechanistic design, I'm hoping that this course can now point you in the right direction, and you know exactly what to look for, what not to look for, how to go through it, what guides to look for, and what the guides mean. So that's the objective of this course, and I hope that makes sense. So these are the advantages of using the mechanistic empirical pavement design. Okay, so let's move on. Hi guys, so I just wanted to quickly take you through the design process. So this is just a design flowchart for the mechanistic empirical design. Okay, so we start at stage number 1. Okay, so at stage number 1, right, that's the evaluation. So you have your input for design, you look at your factors, climate and the environment analysis, you look at the new materials you're going to use. So that can either be hot mix asphalt, unbounded granular material, or soil embankment material. And then you look at your traffic analysis, your ESALs, or like I like to call them, the EATs, and your growth rate, right? And then after that, obviously you've got your project general information, you've got the paving material that you can use, like depending on how unique the project is. Then obviously you've got your design criteria, and then like as we've been mentioning before, and then now you have your trial pavement, right? And then obviously you have your estimated trial section, your estimated thicknesses from the, like for example from the ASHTO, right? And then moving on, you define your okay. So then after that, if you have that, you go down and then you estimate your E's and your effective E, your effective T, and AC here means asphalt course, like the layer, and you use the NCPHR 092 methodology. Then you estimate your pavement response. You develop you use a finite element program, and then you calculate the incremental damage. That will be more the empirical side, using empirical equations. Then distress transfer functions of the pavement, and then obviously the distress models, and then you locally calibrated mechanistic empirical design performance model. And then you have your unbonded layer, and then you have your asphalt course rating, and then you look at performance. So you look at serviceability, like will it have alligator cracks, or in South Africa and I think New Zealand, Australia, we call them crocodile cracks because we don't have any alligators. You look at fatigue, then you look at cracking, and then obviously you look at the roughness, the IRI, and then you see if your design criteria has been met. If it has, then that's done. If it hasn't been met, then you go back here, and then you define the pavement layer again, and then you go through the process until your design criteria has been met. So this is like the basic process of going through the design. So I just wanted to take you through the flow chart of how you go through a design. So these are all the steps. We've looked at all the steps. You guys now know how to use the AASHTO 1993 empirically, so you can use that. And of course, you guys will need to have to look at using a certain software. So the softwares that are on the market, I'll go into that in a bit. I'll go into that just now, but there are softwares that are in a market. So, but this is just the basic flow. All the documents like the NHC, HRP, these are all free and they're online. You can most definitely get them and go through them. I think they even have design examples. There's so many design examples. If you go to the Highway Association of America or the Federal Highway Association of America, even the US Army Corps of America, they have so many design guidelines. They have so much material that you guys can now continue to boost or to build up from what you've learned from this course. And that's the whole idea, because I think it would take me weeks to be able to go through everything bit by bit by bit. But now this is just a springboard, so you can spring off and be able to go through everything that I've gone through on your own time or by yourself. So yeah, let's move on to the next slide. So in summary, the benefits of the mechanistic-empirical approach is the ability to accurately characterize the in situ material, including subgrade and existing pavement structures. So this is typically done by using a portable device like a FWB to make actual field deflection measurements on the pavement structure to be overlaid. These measurements can then be input into the equation to determine the existing pavement structure support. Often it's like a back calculation and the approximate remaining life of the road. This allows for a more realistic design for the given conditions. Like I said, you can use both empirical and mechanistic methods to find your answer. So this is just affirming or cementing everything that I've been talking about, and why this method is one of the best methods, especially if it's for, let's say, rehabilitation of a road section. Let's say you've got a highway that's been worn out and you're trying to rehabilitate it. The mechanistic empirical method will most definitely be the best method, and you know, you'll save money. You'll use the exact aggregate. You know that your aggregate matrix are on point. You know that everything you're doing is most definitely going to work out, and you have your models and you've tested it and you know exactly how long the road is going to last. So what this does is it helps you optimize the design. It also reduces risk of failure, and it removes you being liable or being found negligent when it comes to design in case the contractor messes up on site. If the contractor fails to perform on site and you designed your design to last for a certain amount of time and it fails, then you can go back and the contractor has to be accountable because they did not meet your design requirements. Of course, like with everything, there's a certain minimum amount of tolerance, and you must also definitely put that in your specification, and you must make sure that there are certain things that the engineer needs to sign off. For example, the existing ground California bearing ratio, you need to make sure that it is as you designed it for. And also, like here, like we're talking about the existing pavement, you need to make sure all those parameters, you check them and they're correct, or they were checked by a competent person to make sure that your design is not wrong. Because if your design is wrong from first principles, then you're most definitely going to be in trouble. That will knock on to everything else, and then it might fail and people might get hurt, and you are most definitely legally liable. So always make sure you cover your backside every single time when you're going into these spaces, especially when you're working with big government departments. Make sure you cover your backside. And also it's for you as an engineer, because you know we've taken certain oaths. For example, like in South Africa, you have to sign an affidavit and swear that you operate within the parameters of the Engineering Council guidelines. So we've taken certain oaths and we've signed certain documents to assure that we'll operate as professionals within a professional space. So always make sure that you are not found wanting and you are not found liable. It's very important. And always make sure in your specification you make it understood that during construction the risk then lies with the contractor. They need to perform as per your design. So yeah, very, very important. So now let me just take you guys through some of the example softwares you can use for carrying out these designs. Okay, so our first software is Circly. So Circly 7. So Circly is provided by an Australian company, but it's also used by New Zealand, Australia, of course. And it's used for, you can use it for rural or urban design. So Circly, but Circly is a mechanistic, that's a mechanistic design software. So it's for only mechanistic design. So you can use Circly for mechanistic design or your mechanistic designs. So Circly is most definitely one of the best. Yeah, especially if you're operating in New Zealand or Australia. Circly is the one. Then there's Ashtore Pavement Design. So Ashtore Pavement Design is most definitely, it's a mechanistic empirical design. So this is version 3. I think it's the latest version. So Ashtore, guys, go have a look at it. There are a lot of tutorials, you know, you can go through it. So yeah, Ashtore is most definitely, that's the one. I advise using Ashtore if you're going to have a mechanistic empirical design. Most definitely you should use Ashtore. Like Ashtore is it's one of the best, and it then encompasses, which is why I come back and say why I was then referencing Ashtore and because these guys have gone through this and they know exactly what they're talking about, and they're so open to helping you. You can email them with problems and explain where you're going wrong, or if you're doing your design correctly, if you and your supervisor don't know exactly what's going on. So this is a good skill to have in terms of the roading space. So yeah, this is most definitely something to look into. So yeah, without any further ado, let's call it a day. Thank you guys for enrolling in this course. Thank you guys for giving me the time to show you my knowledge or to share my knowledge with you guys. It's also good for me because when I prepare these lectures, I go back to things that I've been doing, things I've worked on, and I also get to remember things that I've done before. So after preparing this course, or after preparing these slides for this course, I'm now back at my peak when it comes to pavement design, because I was going through it so that I can give you guys this knowledge, and I'm very, very grateful for allowing me to give you guys this knowledge. Thank you very much. Please continue to support me. You can look for me on LinkedIn, talk to me on LinkedIn, send me a message. You can follow me on LinkedIn. I don't have a whole lot of followers, but you can follow me on LinkedIn. Always happy to talk to you guys. You can talk to me on LinkedIn. You can comment on the things I post. I always post different designs or various things that I'm working on. Please feel free to post me on to connect with me on LinkedIn. Always happy to talk to you guys. If I have time, I'll most definitely do more courses, but obviously I work full time, so I'm a bit busy. And also I tutor mathematics. If you're struggling with mathematics for any level, feel free to get in touch with me. I also sell mathematics courses, I sell ebooks, I do all that. So you'll most definitely be seeing more courses from me, and hopefully I'll get better with time. Thank you so much for sticking around. I'm really, really, really grateful, guys. And I hope I helped. Please give me feedback so that I can improve my craft. I'm always happy to hear criticism, because I know that no one is born perfect. I wasn't born an engineer, I became one, so hopefully I can become a good course provider also.